Hi there. Thanks very much for tuning in. So I want to talk today about OpenFOAM on AWS with Graviton2. So my name is Neil Ashton and I'm Principal CFD Specialist Solution Architect at AWS. And I first of all want to say a special thanks to Karthik, who also works here at AWS as a HPC Solution Architect, and Ollie, who works at ARM, for their collaboration on this effort. It's actually probably those two who should be speaking here today, but nevertheless, I hope this will be interesting for you. So first of all, please go and listen to my colleague Stephen Sachs' talk, which is probably going to be much more interesting than this one for most people, and it's about moving HPC workloads onto AWS and Graviton2. So please jump over and listen to that. It's in the same playlist channel. So I wanted to talk today just very briefly about the things that we've been doing with CFD and Graviton2. And I just kind of wanted to take a very brief moment to say that, the whole industry, whether it's automotive or aerospace or manufacturing, is going about this big change at the moment, designing these great electric cars and electric aircraft to drive, improvements in efficiency and reduce emissions. The tried and tested way to do it at the moment is using wind tunnels. That's kind of the default. CFD is used, but wind tunnels are used a lot because they're much more trusted, but they're expensive and they can often cause delays in terms of production because you've got to, design this thing, then you're going to go manufacture it, make it, take it to a wind tunnel, blow the air over this car, plane or city, and then decide is it good or not. Now, of course, the idea with CFD is that you don't need any manufacturer and that you can just, solve these Navier-Stokes equations in hopefully a much cheaper and faster fashion than you can by doing some, manufacturing taken to a wind tunnel. But of course, the question is it accurate? I'm not going to go into that bit here, but I will say that the accuracy is absolutely linked to the HPC cost. And typically CFD is HPC hungry, it's a tightly coupled application. But if we want to just use more and more HPC so we can get more and more accurate CFD to reduce, wind tunnel usage, for example, and help companies or researchers to, develop new products, the problem we often get is that people are stuck in their HPC queues. I had it, I'm sure many of you have it, that you're stuck in a queue to submit your job, whether you're in the university or industry, or you've run out of disk space. I used to get emails all the time from sysadmins saying, please delete some disk space. So obviously, the AWS angle is that we would like you to not have those bottlenecks, and so move from the model on the left of kind of a fixed size to the model on the right, where you can just elastically scale. Now, of course, we like to say that we have the broadest and deepest platform voice, which is true. You can see there's a huge range of different instance types. But I wanted to focus today, of course, on the Graviton2. And I think Stephen in his talk did a good job of talking a little bit about the evolution from the first Graviton to the Graviton2. But I wanted to focus in particularly on its use for OpenFOAM. Now, OpenFOAM is a popular open source CFD code. And I want to show you how that specifically has been used. And this is the work that Karthik and Ollie and I have been doing on this front. And I wanted to summarize first just in a kind of single instance. Why does this matter? Well, this is an example of running a OpenFOAM benchmark tutorial, the motorbike case for anyone who's used to using OpenFOAM, 4 million cells. And this is the runtime in hours to run it for 5,000 iterations. No modification to tutorial other than mesh increase. This is just being compiled basically out of the box. If you look, I'll present it in a moment. Ollie has done a great job of showing how simple it is to compile OpenFOAM on ARM. And we simply just follow those instructions. And we're using v1912, so you literally don't have to do anything. You can actually just use the GCC compiler if you want to, because that actually is just no mods whatsoever. This is the single node performance. So you can see we've got a range of instance types from our C5N, which is a kind of Intel Skylake. We've got the C6G, so this is obviously the Graviton2. Then we've got a range of other AMD and Intel instances of varying ages and flavors. Given this is a very brief talk, I won't go into all of it. what I'll simply show you is that our users have a clear choice on the sort of instance type they use. Now you can scan across this graph and you can see that the C524X large, so Intel Cascade Lake, actually give us the fastest runtime for a single node test. Of course, these have different core counts, memory bandwidth, but these are the choice that the end user has when they pick a full instance type. But what's interesting is, of course, then if you look at the price, and these are just the on-demand public pricing, you can see a very different story. That now, yes, the C524X large was the fastest, but it's not the cheapest. And the cheapest is the C6G 16X large. And this is why we were writing a blog to demonstrate this. If you Google the AWS OpenFOAM ARM, hopefully that blog will come up. And you can see how it is worked to say, hey, actually, if you care about price performance, then by far the winner is the Graviton2. Now, this is just a single node test, but what about in a multi-node? Well, we actually used AWS Parallel Cluster to do this, and again, Stephen talks about it in his talk, where we can just simply create a cluster, whether it's x86 or ARM, and then just spin up the cluster, jump on, install OpenFOAM, and get running. And this is a kind of an example script that you can take. And again, I encourage you to watch Stephen's talk on that. But essentially what we saw was that here we have a scaling of a 222 million cell case, so not 4 million, but much bigger. This is like a full industrial size case. And yes, the C5N, the Intel Skylake with EFA, scales out really well. The lack of EFA on the C6G 16X large does mean that you don't get as good scaling, although that's similar to the C524X large that also doesn't have EFA. But what you see is that still the price performance, even for a very large case, even on multi-node, and even with the C6G without EFA, still gives you a considerable reason to use it. And so again, this is why we wrote the blog post to kind of highlight the fact that if you're running OpenFOAM, then you should absolutely consider the C6G, or of course the M6G if you need higher memory, or the R6G to run your OpenFOAM cases, because we really feel that you can get a very similar performance. Okay, maybe not as fast, but you can get a really good cost per simulation. And for many people, this is actually the most important thing. So what about another couple of quick ways to do it? Well, how about collaborations? Well, you could just spin up an EC2 instance or parallel cluster for multi-node, jump on, install OpenFOAM and run your cases. You could then save it as an Amazon machine image and just share that with your collaborators. Share it with their account ID, or if you really wanted to, you could make a community image out to that. So anyone can just jump in and use your installation. They could therefore jump in and have exactly the same setup as you. And of course, that's better than just pulling it from Git and installing the code. You can even have exactly the same operating system and environment, which really reduces the kind of uncertainties or differences between. You can replicate or repeat other people's work. Of course, you can also do real-time collaborations, because you could spin up an EC2 instance or parallel cluster, install OpenFOAM, and then just share access to your collaborators, let's say via SSH keys, or you could then work in it, in a joint academic project, let's say. This is really the power, I think, of AWS, that you can also collaborate in those sort of ways. So hopefully I just wanted to show you very briefly some of the work that we've been doing in looking at OpenFOAM and ARM. This is just the start. There's lots of very exciting stuff coming up, so please stick around and kind of wait for that. Hopefully a couple of quick ways that you can enable some real-time collaborations with colleagues using AWS, OpenFOAM, and the Graviton2 instances. So with that, thank you very much for listening, and I hope you enjoy the rest of the ARM HPC talks.